So hello friends, in this video we are going to discuss our Codechef Starters 153. So basically today's contest were very easy, it was on the basic mathematics and nothing else and common sense. So now let's discuss our first problem statement. The name of the problem is butterfly. Let's read the problem statement. In your garden there are exactly R red butterflies, G green butterflies and B blue butterflies. Okay. And there are exactly are red flowers, G green flowers and B blue flowers. To determine whether it is possible for every butterfly to feed on exactly one flower such that no two butterflies feed on the same flower. Okay, means we have been given two types of butterflies, red, green and blue. Okay, and flowers also red, green and blue. So basically no two butterflies means this red butterfly will not feed on the same colored flower. Okay, this red butterfly has to be feeded on green or blue. Okay, so in any one of them it can feed, but also each butterfly can feed only on one flower only. Okay, so these are basically the main constraints we have been given. The second point is basically the same only, that each butterfly will feed on a flower whose color is different from its own color. Okay, means red will feed on green and blue, green will feed on red and blue, and blue will feed on red and green. Okay, different colors. But each one butterfly can only feed on one flower only. So keep this in mind. So basically, let's move forward. We have been given the uh, n space separated integer. Sorry, we can say the colors over here. So we have to print either yes if it is possible to feed appropriately or no otherwise. Let's take an example. It will give us a more concise and clear idea about how we can solve the problem. So we have been given, first of all, let's read the input. So basically we have been given 254. Okay, the and it is given in the format of red, green and blue. Okay, so basically in this format we have been given, but these are the colors of both flower and butterfly, both the colors we have been given. So now let's read over here. So we have been given two reds, so two red butterflies. Let me change the color. Okay, so it will be more easier for you to understand. Two red butterflies, then five green butterflies. Where is the green color? Okay, five green butterflies, one two three four five. Okay, five green butterflies and four blue butterflies. Okay, four blue butterflies. So basically, in this way, we have been given the all the butterflies and their colors over here. So now we have to see that if each butterfly is able to feed on the different color. Okay. So now let's see. The red will feed on either green or blue, as we know. Okay, either green or blue, and the green will feed on what? The green will feed on either red or blue. Okay, and the blue will feed on either red or green. So these are basically either green and blue. So in this case, we have total five greens and four blues over here. So let's suppose it will feed on the green flower over here. Let's suppose the red will feed on green flower. Okay, the next red will feed on either blue or we can say green over here. So let's suppose we can say blue. Okay, so and then now the green flowers, all the green flowers, they can feed on only on red and blue flowers only. So we have total of four or blue flowers and two red flowers, and we have completed with already three blue flowers. Means one blue flower. So we have left with only three blue flowers. Okay, we have total four blue flowers, and we have completed one blue flower. So now we have three blue flowers left and two red flowers. So now we have all over totally five blue and red flowers. Okay, so now let's move forward. So basically here will come from the four blue flowers and two red, means three blue flowers. Okay, blue, blue, blue. Okay, three blue flowers and two red flowers over here. Okay, and the blue flowers will be matched with the green flowers or red flowers. But now here, here as we are able to see that we have completed all red flowers. So basically now over here we will match with the green flowers. So it will be green, green, green and green. Okay, so here we have completed with all the flowers over here. Means all the respective butterflies are able to feed on the different flowers, and each butterfly is feeding on a single flower only. So now you can see that it is possible that they are able to feed. So our answer will be yes over here. Okay, so let's see how we can solve this problem statement. Basically over here, let's see one edge case. Let's just notice one edge case. 315 over here means three red, one green, and basically if five blues. Okay, so as you are able to see over here, we have total of three red and one green, means total of four colors. Okay, total we have four color, and this is total of five color. Okay, this is in total we have are having five color. So basically over here, her blue can match with either red or green, but as you are able to see that there are total only four colors. So how can so we will be left with one blue color over here. Okay, let's visualize it over here. We have total of five blue colors. Okay, and also we have three red colors and one green color. So okay, so three red color and one green color over here. But now, how what will happen for this blue color? It will be left empty over here. Okay, so here comes the solution of our problem. So now we will check over here. There comes the solution of our problem. We will check that if our, let me change the numbers over here. This is red, green, and blue. Okay, this must be basically red plus green. Okay, this must be basically red plus blue, red plus blue, and it is basically green. Okay, and this is basically red, green plus blue. Okay, so now basically you are able to see that if our two colors means red plus green is less than the means if two colors, sum of the two colors over here, we have been given total of three colors. Okay, we have been given total of three colors over here. But what if means RGB? What if the sum of these two colors is less than the sum of these colors? Okay, means if R plus G is less than the blue color. So how we can map these solutions? Means how we can map the flowers over here? The butterfly will not be able to feed on each flower. So in this case, our answer will be no. So we have checked for each condition. If red plus green is less than blue, or our red plus blue is less than green, or our green plus blue is less than red, then we will print no, or else we will print yes. Okay. So basically, this was the our first problem statement, the butterfly. Now let's move on to a second problem statement. Basically, our second problem is make arithmetic progression. Okay. So basically, we have been given three positive integers, x, y, and z. In one operation, you can choose one of these values and change it to any integer of your choice. Find minimum operations required to make the sequence x, y, z an arithmetic progression. Okay. So basically, what is the basic rule of an arithmetic progression? The basic rule is what? It's simple. Well, if we have been given x, y, and z, Okay, so this is the order over here. So if our y minus x is equals to what? Z minus y. If it is so, means if they are equal, so means it is an arithmetic progression. Okay. So basically, what if the numbers over here means if our y minus x is what not equals to z minus y, then in this case, what you can do? You have to just do some operation. Means you can just change the integer over here. Means what you can do in one operation, you can choose any of these values and change it to any integer of your choice. I mean, you can choose any integer. You can choose either positive, either negative, or you can say zero over here. Okay, you can choose any integer of your choice. Let's understand it with the help of some examples. Okay, so basically, we have been given our first example is 258. Okay, 2, 2, 5, and 8. Okay, so basically this we have been given. So you have to check that whether it is an arithmetic progression or not. Okay, so if it is yes, so we have to return 0, means no operation we can perform. It is already an arithmetic progression, or else you have to return the minimum number of operations. So this is x, y, z. Okay, now let's see if my 5 minus 2 is equals to what? 8 minus 5 means y minus x is equals to z minus y. So 5 minus 2 is 3 and 3 is also equals to 8 minus 5, which is also 3. So basically our operation over here is correct, means this is an arithmetic progression. Okay, this is an arithmetic progression. So we are printing our answer as 0. 0 why? Because we have to perform no operation, no change operation over here. Change operation in the sense we can see the next example. Like this is 7, 4, 3 we have been given. Okay, basically over here, what is the difference over here? 4 minus 7 is what? It is equals to what? Minus 3. And 3 minus 4 over here is what? It is equals to minus 1. So basically over here, minus 3 is what? Not equals to minus 1. Okay. But you have to make it an arithmetic progression. So for making it an arithmetic progression, you have to perform some operation on this array over here. So that your answer means their difference on both the sides will be equal. So basically, we will start from the last position over here. Okay. So for example, I have changed it to basically we can say 1 over here. For example, I have changed it to 1. Okay. Let's make it 1. So our new array will be what? Our new array will be 7, 4, and 1. Okay. So now the difference of this is what? Minus 3. And now 1 minus 4 is what? It is also minus 3. So now minus 3 is equals to what? Minus 3. So yes, it is an arithmetic progression. So our answer will be what? 1. Because we have performed only one operation. Means we have changed only one number over here. Okay. So this is the means explanation for this example. So here comes then edge case. Okay, let's discuss an edge case over here. What if any number comes over here like 7, 5, and 4 over here? Okay, so basically 5 minus 7 is what? It is minus 2. Okay, and 4 minus 5 is what? It is basically minus 1 only. Okay, so as you are able to see that we have to change only this number. Okay, so that our answer will be equals to this number. Okay, so we don't have to touch any of these two numbers. Just perform only on this number. Why there is a need to perform operation on all the numbers? Just change only a single number over here. Like you can change 4 to any number. Like you have to perform the operation like 4 minus 5 is what? Minus 1. So for example, you can make it 3. Okay, you can make it 3 over here. Okay, like it will be now 7, 5 and 3. 7, 5 and 3. Now let's see what our answer comes. 5 minus 7 is what? 5 minus 7 is minus 2. Also, 3 minus 5 is what? Minus 2. So basically minus 2 is equals to what? Minus 2. So we have to perform only one operation over here, one single operation. So our answer will be either 1 or 0 only. So this was the basic solution for it. Okay, means we will check over here if our array given is already an arithmetic progression, just print 0 or else print 1. Okay, so basically we have completed with the second problem. Now let's move on to our third problem statement. Okay, so our third problem is basically another game. Okay, it's bit tricky, but your brother has solved it. Okay, so another game. Alice and Bob has decided to play yet another game. Alice will give Bob a non-negative integer. Means Alice will give Bob a positive integer k over here and a permutation p, whose length is what? N over here. So Bob's goal is what? His goal is to sort the permutation in ascending order. Okay, you have been given an integer k over here and a permutation p. Okay, whose length is what? Whose length is n over here. So your goal is to perform the sorting operation on p. Okay. So to achieve this, Bob can perform following operation, however many times he likes. So choose two indices I and j such that pi and plus pj is less than or equals to k and swap pi and pj. So we have to return the minimum value of k for which it is possible for Bob to sort the permutation. Okay. Let's discuss it with an example. Basically, we have to perform sorting operation over here. If our array is already sorted, then we have to return just 0. Okay, means no minimum number of we can say operation or we can say moves are required over here. Let's see. So basically over here, we have been given 1, 2, 3, 4, 5. Okay, as you are able to see that this array is already sorted over here. It is already in a sorted form. So just our answer will be 0 because we didn't need any of the number so that we can perform operation swapping operation on it. Means we didn't require any k over here. So let's move on to a second example. Our second example is basically 3241. Okay, 3241. Okay, so basically over here we have to choose any of the one number. Okay, we have to choose any of the number one number whose sum is what less than or equals to the given numbers. So basically over here the sum of this number is what? 5. Also over here the sum of this number is 5 means adjacent numbers. Okay, as you are able to see you have to choose the adjacent numbers over here means pin plus pj. So basically see over here. So 4 plus 1. 4 plus 1 is basically what? 4 plus 1 is 5 and 3 plus 2 is also 5 as you know. So for example we have chosen a number 5 over here. So 4 plus 1 is what? 5. Means it is less than 4 plus 1 is less than or equals to what? 5 in this case. So we will just swap. Okay. So our array will be now 3, 2, 1, 4. Okay. Now there are another numbers also which can be swapped. Means our array is not sorted until now. Means these two numbers are coming in between over here. So because of them, our array is not sorted up till now. So now let's see that the sum of this number means 3 plus 1 is what? Less than equals to what? 5 in this case. Okay. Means 4 is what? Less than equals to 5. So we can swap over here. So just swap these two numbers. So now it will be 1, 2, 3, 4. Okay. So as we are able to see that our array is what? Sorted over here. And what number we have chosen over here? for the means k what we have been chosen is 5. So our output over here is what? 5 in this case. Same for this number 2 1. So let's choose a number 2 plus 1 is what? 3 over here. So let's choose a number 3. So basically over here 2 plus 1 is less than equals to 3 in this case. So we will swap. Okay. So after swapping, what is our answer? Our answer is basically a 1 2. So after swapping, our array is not over here is sorted over here. So we will just output our answer as 3 because we have chosen 3 number as here. So how you can solve the problem statement over here? Okay, let's check. For example, let's take this number only 3241. So basically, let's suppose this is our B. Okay, let's suppose this is our B, and we'll perform some operation over here. Let C be our sorted of B, means our C will be 1 2 3 4. Let's suppose we have means assumed we have done our assumption 1 2 3 4. Okay, so we have done this. So basically, if we will check that if our B means the 32141 is equals to the sorted row, means if it is already sorted, just print 0. Okay, just simply print 0 and continue. We will just continue over here. Else, what we will do means we will run a for loop, means in reverse order. We will run a for loop in reverse order. Okay, means in this order, we'll check from last element to first element. So basically, let's run a for loop. So for I in range, for example, n minus 1 till 0 means from n minus 1 to 0 over here, and we will be decrementing our for loop by minus 1. Okay, so basically we will be decrementing over here by minus 1, means we can say it as I minus minus. So we will check if our b of I is what not equals to our c of I. If our b of I is not equals to c of I, we will check our d as maximum of b of I comma c of I, b of I comma c of I, and just add a break over here and print our d, and just simply print our answer as d. So this was basically the pseudocode for the problem statement. Let's see. We will first of all sort our array over here and check if it is already sorted, just print 0, or else we will run a for loop from n minus 1 to 0, and we will check that if the element in the unsorted array is not equals to the element in the sorted array, we will find the maximum of that element and simply break, and then find the then just simply print d. So basically, let's understand it with the example as 3241. This is basically our b, and our c is 1 2 3 4. Basically, our b is what not equals to c. So we will go on to for loop. Just move on to our for loop. So in for loop, we are checking from n minus 1 to 2 minus 1, means our a is what basically means the size of it is 4. Okay, so 4 minus 1 means basically 3 2 4 1. It is what 0 1 2 3, means from 3 to 0 we will check. From 3 to 0 we are going to check. So basically for our I equals to 3, for I equals to 3 over here, our number is what? For I equals to 3, our number is 1. So means b of 3 over here is not equals to c of 3. Means basically 3, 2, 4, 1 and 1, 2, 3, 4. Over here, our b of 3 is what? Not equals to, means our 1 is not equals to what? 4. So our d will be maximum of b of I and c of I over here. Okay, so our maximum of b of I and c of I is what? It is basically 4 in this case. Okay, so now let's move forward to our next example, and just we will find a break over here and just print our answer. Let me run it for you. Okay, so as you are able to see that it's giving the expected output over here. The code is running properly. So basically I have forgot to tell you one simple condition over here. I just missed one condition of adding 1. Okay, we will just simply add 1 to it. Okay, we will just simply add 1 to it. So means our number will be added over here. So basically in this D, our 1 plus maximum of 1 comma 4. Okay, maximum 1 plus maximum of 1 comma 4. So basically maximum of 1 comma 4 is what? 4 over here. So our D will be 1 plus 4, which is 5. So our D has came over here as 5, and just we have break the statement and print D. Okay, and just simply print D. So our answer will be 5 in this case. Okay, I think you have got this problem. Okay, first of all, we have sorted the list and checked that if it is already equal. If it is equal, we will continue, and then we will run a for loop in reverse order. If the last elements of both the list is not equal, we will apply the formula of finding the maximum and of the last elements of both the list and add 1 to it, and simply break the statement and print that element. Okay, so now let's move on to our next problem statement. Okay, so basically given an easy version, and also it is an easy version. Let's discuss. You are given a tree containing n vertices and n minus 1 undirected edges. Okay, we have been given the edges of a tree. You have to color each vertex of the tree either red, green, blue, and green. Okay, means it is of the means it is the game of colors only. Okay, red, green, and blue. So basically, each vertex must receive exactly one color, and there should be at least one vertex having in each color in the end. Means the vertex must have each color in the end. So for a vertex, you define score u to be sum of the distances from u to the closest vertices of the other two colors. So first of all, let's understand these two lines over here. So basically, over here is a tree we have been given. Okay, simple tree we have been given over here. 1, 2, 3. Okay, and the distance between is, so basically for 1 over here, the distance will, for 2 and 3 will be what? It will be 1, and what, basically 1 plus 1, which is 2. So it will be 3. Okay, means what I mean to say, distance from 1 to 2 is what? 1. Okay, and then distance from 1 to 3 is what? 2. So our so this I mean to say. Then for 2, from 2 to 1, our distance is what? 1. And then from 2 to 3 also our distance is 2. So our answer will be 2 over here. Then from 3. From 3 to 2 our distance is 1. And then from 3 to 1 our distance is 2. So it total will be 3. So now we have to return the total answer, means 3 plus 2 plus 3, which is basically the 8. Okay, so we have got our answer as 8 in this case. So this is the basic meaning of this over here, means this lines. Okay, this whole the basic meaning of this whole paragraph over here. Okay, so basically our task is to output the minimum possible beauty of the tree that can be achieved over all valid kernels. Okay, we have to return the minimum possible hull over here, minimum possible hull beauty of the tree that can be achieved over all valid colorings, means different colors at each edge. Okay, so let's read our first input. 1, 2, 3. Okay, it's basically similar to our first example only. 1, 2, and 3. Okay, so basically it is similar to our first example only. So no tension over here. Okay, so in first example, basically here the distance in each node is what 1 1 only. Okay, as you know, it will be very simple over here. Let's see this only. Basically, it is the explanation for the first example only. Means we have got our answer as 8 over here. Okay, but I have not discussed the colors over here. Okay, so basically the colors for this it will be red. Okay, then for it will be green, and then for this it will be blue. Okay, for one it will be red, for two it will be green, and three it will be blue. So in this way we have got three colors over here on each node. Okay, let's discuss a more bit harder example. Okay, our second example over here. So basically we have been given 3 to 4, 5 to 3, 2 to 3, and 1 to 2. Okay, so how basically the tree will be created over here. Okay, basically first of all start from the lowest one, 1 to 2, then we have 2 to 3. Okay, 1 to 2, then 2 to 3, then 3 to 4, and 5 to 3. Okay, 3 to 4 and 5 to 3. Basically let's remove this arrows over here. It is creating some confusion in between you. Okay, so basically this is 1, then it will be 2, 1 to 2, then 2 to 3, then 3 to 4, and then 5 to 3. Okay, so this will be basically our tree in this case. Okay, in this example over here, this example, our tree will be looking like this. Okay, so basically let's consider our three as node red, two as blue, and remaining as green. Let's consider three as red. Okay, three is red. Okay, and two is blue. Two as blue over here, and the remaining ones are green. Means this is green, green, and green over here. Okay, so basically we will start from our node one. We will just start from our node one. Okay, so basically our node one, which is what green over here. Our node one is what green. Okay, as we are able to see. So basically our closest red. Let's see for node one. From node one, our closest red is what? Our closest red is at 3. Okay, as you are able to see. Our closest red is at 3 over here. So basically, For means from 1 to 3, how much is the distance? The distance is basically 2 over here. Okay. So from 1 to 3 means from green to red. Our closest distance is what? 2 over here. Okay. And then closest blue, which is at node 2, I think so. Okay. So basically our from 1 to 2 means from green, the closest blue is what? 2 over here. Okay. So basically from 1 to 2, how much is the distance? The distance is 1 only. Okay. So from 1 to 2 means from green to blue. The closest distance is what? 1 over here. So our total distance is what? 2 plus 1, which is 3 for node 1. It is just for node 1. Then we have to go for node 2. We have to go for node 2, which is basically what? Which is basically blue. Okay. So basically for node 2, our closest red. Our closest red is at where? Let's see. From node 2, our closest red is at blue over here. Okay. From node 2, our closest red is at 3. Means from blue to red, it is 3 over here. 2 to 3. Okay. And then also from uh, we can say green. Our closest green over here is 1. Okay. Means from blue to for blue to red it is 2 to 3. 2 to 3. And from blue to green it is 2 to 1. Okay. Keep this in mind. Okay. So basically over here from our closest red over here is 3. Means from 2 to 3. It is what? Our distance is only simply 1. And then from for our closest green over here, it is for what? It is for closest red. And then for closest green, it is 2 to 1, which is 1 only. Okay. So red and green over here. So total will be what? 1 plus 1, which is 2. Okay. So our 1 plus 1, which is we have got our answer as 2 over here. And first we have got answer as 3. Okay. So now let's move on forward. So for node 3 over here, our node 3 is what? Red over here. As you know, node 3, which is red in color. Okay. Okay. So from 3, the nearest uh, is blue over here is 2. Okay. From 3, the nearest blue is what? Or 2 over here. Okay. So which is at a distance of what? 1. And from 3, the nearest green is what? Either 4 or 5, which is at a distance of 1 only. So let's move forward. So from 3, the closest, what? Closest blue over here is 2, which is at a distance of 1. Closest blue. And then from 3, it is 4 or 5. The closest, what? The closest of green. Okay. So our answer for this case, okay, for this case over here, it is 1 plus 1, which is 2. Okay, let's move forward. For our node 4, for our node 4, our closest is red over here is node 3, okay, which is at a distance of 1. And our closest blue is at 2, which is at a distance of 2 over here, means 4, 3, 2. So we have 2 blocks in this, means is at a distance of 2. So let's write over there is our node 4, which is at which is what? Green in color. So our closest what red over here is basically 3. Okay, 4 to 3 closest red. 4 to 3, our closest red is 1. Okay. Then we can say our closest blue means 4 to 2. Our closest blue is at 2. So our distance is 2 over here. Okay. So our answer is 1 plus 2, which is 3 in this case. Similarly, for it will be node 5 also. For node 5 also, our answer will be 3. Okay. Now let's calculate the total of all over here. First, we have got our answer as 3 over here. 3 as our answer. Okay. Then 3 plus 2 over here, as you are able to see. 3 plus 2, which is 5. Okay. We have done with it. Then 5 plus 2. 5 plus 2 is what? 7. Okay. We have got 2 also. 5 plus 2, which is 7. And then again 7 plus 3, which is 10. And 10 plus 3, which is 13. Okay. So we have got 13 as our answer in this case. So as you are able to see that we have got 13 as our answer. And this was all the solution for this problem over here. Okay, for all the node 1 to 5 over here. And this was a diagram for this. So basically, let's see the code over here. First of all, we have created an adjacency list over here and stored all the values in it. Okay, means red and blue. As you are able to see, we have stored all the values in the adjacency list. Then we have done. We have iterated to each and every element. Basically, over here, we have created an adjacency list. Okay, and stored all the nodes over here. So for this example, our nodes will be, for this example, our nodes basically, let's see over here. Basically, for this example, our R will be what? First of all, the empty list. Okay, then comes the 2. Okay, then comes the 1 comma 3. Then comes 2 4 5, and then comes at last 3, and then again 3. Okay, this is basically the adjacency list over here for this example. Okay, for this example, we have created an adjacency list. Then we will check that if an element means, if an element is single over here. Okay, like this elements, this three elements, 1 2 and 3. If they are single, our d will be incremented by 1. So basically we have got three single elements. Okay, we have just basically got three single elements. So our d will be equals to what? 3. Okay, and our e will be a minus d. A is what? A is basically let's see what is our a. A is basically over here 5. Okay, so basically 5 minus 3, which is equals to what? 2 over here. 5 minus 3, which is equals to 2. So now we will apply the formula. Now what formula of this? F equals to d into 3 plus e into 2. Okay, so this formula we have applied over here. So it will be 3 into 3 plus 2 into 2. Okay, so it will be basically 9 plus 4, which is 13. So we have got our answer as 13 in this case. So this was the basically the explanation for our problem statement, means last problem statement. Okay, so and this was basically the adjacency list over here, or we can say the explanation, node wise explanation. Okay, this was basically the node wise explanation for all the different colors and the different nodes over here. Okay, and this was basically the tree for this problem statement. Okay, Basically, the contest was easy over here, and there was a bit use of mathematics. Okay, and the 50% use of data structures over here. According to me, it's for the tree problem only and nothing else. So this was basically a simple greedy approach and nothing else. It was basically a greedy approach over here. So thank you friends. If you have any of the doubt, you can ask me in the comment section. Okay. So thank you friends.